All right, folks, I'm showing 10 after the hour, and I'd like to go ahead and reconvene. First off, as I mentioned, if anyone is dialed in and did not get a chance to introduce himself or herself, please go ahead and do so at this time. We have shy people out there. I can see your names, but I'm not going to put you on the spot.
All right. Well, my name's Sharon Hertzcom from CICESE and part of the CIGOM consortium in Mexico, which is the consortium for research for the Gulf of Mexico.
Welcome, Sharon. Glad to have you.
Thank you.
I'm really excited moving forward about the prospects of interacting with Mexico on a grander scale. We have done so in the past, and it's kind of faded. But now I think we're about ready to see it re-energized, and also with Cuba. I think they're major players, and they should not be ignored. We should try to do everything we can within the bounds of our own laws and what have you. But it's, I think, a very exciting opportunity that's on the horizon.
Thank you. I think that's wonderful, and I'm sure CIGOM would be very interested in discussing that.
Absolutely.
We'll do that through Jorge. Thank you.
Great. Okay, thanks, Sharon. We'll go ahead then and get started. We have our presentation on the hurricane glider plan and operations with Bill Lingsch, who's on the IU staff, actually the GCOOS staff, Dr. Kerri Whilden from Texas A&M, and with inputs from Kathleen Bailey, Gustavo Goni, and Scott Glenn. There's a lot of people getting involved in the world of gliders very much collaboratively now, and the Navy included, which is very encouraging. So without further ado, I'll turn the presentation over to Bill.
Thanks, Joe. Thanks, Jorge. Glad to be here this afternoon. Just as Joe said, I work for Carl and Kathleen Bailey, Carl Goldman, as the Underwater Glider User Group Coordinator, UG2, and assist in other staff, just such at projects just like the Hurricane Glider Plan. So the way we're going to sort of frame this, Dr. Kerri Whilden and I, is I'm just going to give sort of a broad overview of the Hurricane Glider efforts, the extent of those efforts, and then we'll drill down into the Gulf of Mexico, which everybody's really interested in, and Kerri will get a little bit more into the science end of it. Next slide. So the purpose of the glider ops is using buoyancy gliders and utilizing all NOAA and its mission partners to monitor the temperature and salinity in that upper 100 meters of the ocean to improve the ocean representation in the ocean component of those coupled ocean atmosphere models, and to hopefully improve hurricane intensity track and forecast. Track and intensity. Next slide. And I just want to kind of say up front too, for that slide, is our intent is not to be chasing hurricanes, but to get that ocean right well in advance of the storm. So I just want to be clear on that purpose as well. Next slide. So this is just a quick cartoon of just put into perspective. Jorge talks about stakeholders and whatnot, and I just threw together just to sort of frame where gliders play in the picture of eventually feeding a decision process. You have and these aren't all inclusive observations, but just showing that you need those observations to actually go into to inform the models and perform for the predicted environment, feeding those not only ocean models, but the coupled air ocean models and surge models. And then the next step when you get up into performance is you start thresholding some of the outputs like surge. And if you know the surges are going to be a certain height or whatever, then that information will drive the decisions of the emergency managers to say, okay, these areas or these areas do not. And hurricane track, obviously, and intensity plays all a role in that. So just a quick cartoon to sort of frame what we're doing. Next slide. So without partnerships, obviously, that's what makes all this possible. And I won't go through each one of these, but you can see it's a lot of folks on the team. And it's all very interactive. It's very collaborative. If you sat in on the meetings, you'd realize that. I can't overemphasize the collaboration and sharing of information as we perform this task. Next slide. Okay, so back up. I just wanted, I thought there was a slide in there. I want to emphasize that Kathleen Bailey is the lead on this effort on pulling all this together. This is no easy task. It's actually a year-round effort that we get together on bi-weekly meetings. And then when we hit the hurricane season from June 1st to the end of this month, we go to weekly meetings. And she's coordinating all the regions, all the partners, assuring that the data assembly center, known as the DAC, is getting the data. And in addition, she's informing all of our stakeholders, both inside and outside NOAA, as well as upper management. So kudos to her. This was her first year doing it and has done a super job. So thank you, Kathleen. Next slide. So again, I mentioned it's not about chasing hurricanes. It's about really tracking these essential ocean features in the different regions that are impacted by the hurricanes along the US coast. And these features are directly linked to rapid intensification and also weakening of storms as well. And a lot of these features occur very close to populated and vulnerable coastlines where you can have rapid intensification. They're very challenging to model, especially without observations. And they provide the gliders provide that targeted observations that provides data with great impact on hurricane intensity forecasts. And a lot of, not that this brief is going to get real deeply into that, Kerri will share some of that, but there's a lot of great examples that's being done as part of this project that Kathleen leads in demonstrating some of the impacts to the models. Next slide. So, and of course, you can go out and collect that data, but the key thing is to get it to the consumers that need it. And so this is just showing how the data is taken from the actual gliders, via satellite, and taken really two routes, one through OAR, AOML, and the other through the Glider Data Assembly Center, and getting to the Data Buoy Center where it gets out to the National Weather Service and the telecommunications gateway, and the users out there can grab that. It's publicly releasable data, and also gets into from the telecommunications gateway back into the NOAA forecast model, RTOFs and HAFs. Next slide. And a key thing with these data, in addition to these data, are QC'd to a level that makes sure that before it's passed and used operationally, that it has quality control, and also that it's has the appropriate metadata attached to it. So it has to meet a lot of standards before it actually gets through that gateway. Next slide. And this is just really a repeat on what I just said. And this is just a snapshot showing in time here. This was June 21st, showing that the blue dots were basically good quality data and that were assimilated into RTOFs. And it's a very, I guess, complicated process, but it works very well. And John Kerfoot up at Rutgers has a lot of influence on how that works. So I appreciate that. Next slide. And here's just some examples over the last couple of years of where hurricanes are making, I'm sorry, where the glider data is making a difference in when it's actually assimilated into the models and reducing the error of hurricane intensity forecasts. So you can see when the ocean data is actually assimilated, the improvement in the actual forecast. Okay, next slide. So in the beginning of the year, as we move into the spring part of the season, we're putting together plans so this, again, it's a year-round effort. We're putting the plans together, and based on the different regions, in this case, in the Mid-Atlantic region, where GCOOS is very involved in leading this, and their partners, putting together, in this case, tracking the Mid-Atlantic cold pool and the Gulf Stream, where Woods Hole also participates in that as well as some of the what we call other mission gliders. But you can see where we actually have planned NOAA/partner that are funded, and planned Navy, and then pending availability. So this year with the Navy assets, initially early in the season, they weren't able to commit as many. They were able to commit 4 gliders. So those 4 gliders were spread amongst the 4 regions early on, with the intent of being able to get an increase of glider assets to the regions sometime more towards the peak of hurricane season. Next slide. And we'll just go through each region just to show the plans and for each of the regions that was done in advance. Again, this is down in the Caribbean and the tropical Atlantic, tracking the warm pool, the freshwater barrier layers, and the freshwater influence that greatly influence intensity. One thing that you can see here at the bottom of the inset, the 3 sail drone missions that were planned, that was coordinated through AOML and in coordination with Catherine Edwards of the University of Georgia. Of those 3 missions, 2 of them actually married up with gliders. So you were actually getting that air-sea interface, the atmospheric piece, as well as down to several hundred meters in 2 of those missions. The one mission that probably a lot of people saw in the media, where a sail drone actually flew into, I believe it's Hurricane Sam, that was not, unfortunately, one of the ones that had a glider associated with it. But that's going to obviously be of great value in research following on. Next slide. So I won't go, I'm sorry, go ahead. Yep. So here, and again, I talked about this sail drone missions, and in this case here, tracking the Gulf Stream, and you can see some of the gliders that from Woods Hole, as well as the ones that are being deployed through Socorro and the University of Georgia as well there, and the Skidaway Institute of Oceanography and AOML as well. Next slide. So this, Kerri's going to talk to most of this. Early on, you'll see that we were very sparse in the Gulf of Mexico, but that story got a lot better with time towards the end of the season now. But tracking the loop current and the eddies and a lot of the freshwater influx from the Mississippi River, that was greatly influencing hurricane intensity. Next slide. So if you took just a snapshot of all the hurricane gliders and other mission gliders that were able to provide data throughout the season, this started from June 1st, and it took us up to just a couple days ago when I took the snapshot. So you can see we had some pretty good glider coverage throughout the season when you look at it overall. Please go to the next slide. And, you know, there's a deployment schedule. I'm not going to go into the deployment schedule, but this is all done up front as well. Next slide. So in summary, the plans and expected outcomes were to have at least 25 gliders be put out, 40 missions, monitoring those essential ocean features that impact hurricane intensity, and the number of days out at sea, and the expected ocean profiles, and the co-located simultaneous ocean atmospheres, especially with the sail drones, as I mentioned. And again, the partners were critical in all this, and without those partners, none of this would be able to happen. And there'll be a lot of research to be done post-season as follow-up to the glider data impact on hurricane intensity forecasts as we move forward. Next slide. So we're going to go into the Gulf of Mexico, and I'm going to turn it over to Kerri. But first, you can see the early in the season from June to August, we were very sparse in the Gulf of Mexico. And obviously the Gulf of Mexico is critical. A lot of hurricanes enter the Gulf, and once they do enter the Gulf, as Kerri has said many times, it's going to make landfall somewhere. And so it's very critical. So we were pretty nervous early in the season with the sparse coverage. Now back in late August, due to some operational commitments on the Navy side, they weren't able to commit their gliders as early in August as we had hoped, but later they did. And so they added an additional 10 gliders to the hurricane intensity efforts, to the glider efforts, of which the group collaborated and agreed that the Gulf of Mexico was where the majority of those needed to go. So of the 10, 6 were targeted for the Gulf of Mexico. One actually had problems, had to be sent back, but beyond that, there's 5 being deployed. Kerri will talk more to that. And then 2 were put up in the Mid-Atlantic, and then in the South Atlantic Bight, 2 others were put, and those are out there and operational as well right now. So a lot of the statistics that we're going to look at we have not compiled them because they really are later in the season, but you can see sort of a quick summary here that of the total 14 missions in the Gulf, that, the Navy gliders actually participated to 8 of those in the end. One of the gliders that went out early actually was out, if you can see it in the June through August, in the northeast part of the Gulf, was actually out for, I believe it was just 100 days. And so it was very successful and in the path of Ida. And so Kerri will talk more to that. And then other mission gliders, we can't ever overemphasize how we rely on, in this case, MODE and University of Southern Florida, and what they provide. Even on a HAB missions, we're getting the temperature and salinity data to the DAC and out to the operational models. And with that, I'll turn it over to Kerri.
Thanks, Bill. I do want to just reiterate some of the things that Bill mentioned. Typically, over the last couple years for glider missions, we've really tried to target right around peak hurricane season. So in the mid-August to mid-October range. And which is great because you end up getting the peak storms where you end up seeing most storms entering the Gulf of Mexico. But it is really important to try to get ocean data ahead of those storms. So what we've tried to focus on, or what we would like to focus on, is trying to get assets out earlier. It's really difficult in the Gulf of Mexico to be reactive for glider missions. Oftentimes, if we have a storm either develop in the Bay of Campeche, or in the case of Ida in the Caribbean, where it was a fast-moving storm, several days ahead of time, even though we know that something's coming, because of the sea state and trying to get assets out on a ship, it's difficult to get gliders out to be reactive ahead of the storm. So the earlier that we can try to get assets out a little bit earlier in the season, the better. Again, to reiterate what Bill had mentioned, towards the beginning of hurricane season in the June to August range, we did have the Navy glider NG645 out. The mission ended up being about 100 days, and it traversed from the Texas shelf break all the way over to just west or just east of Louisiana off the coast of Mississippi. For the West Florida shelf, which is shown on both slides, typically MOAT and USF deploy on the order of every couple months, typically for 30-day missions at a time, and usually centered around red tide research. Okay, so we'll go to the next slide. So what I showed from the last slide is the assets that we had available earlier in the season versus later on in the season. So there really was a stark difference in the available assets, the number of assets and the number of observations that we had from the August to September timeframe. And during that time, 2 storms made landfall in the Gulf of Mexico. The first was Hurricane Ida, which formed as a tropical depression around, I believe, August 26th. Made landfall near Port Fourchon in Louisiana on the 29th. We also had the formation of Hurricane Nicholas in the Bay of Campeche, and it made landfall on the Texas coast. In terms of glider assets available in the vicinity of the storm, we did have the Navy glider, as Bill mentioned, was out and was collecting measurements during the landfall and the traversing of Hurricane Ida. So next slide, please. So this is from the IUS model viewer. It's showing an overlay of operational RTOFs with the hurricane trajectory for Hurricane Ida, as it's probably a couple days right before landfall, and the glider trajectory for NG 645 is shown with a circle around the current location at that point for the trajectory and for the operational model output. Here it's just a couple days before landfall, and the glider is just east of the storm. You can see for the hurricane trajectory that it's following the loop current northwest through the northern extension of the loop current before making landfall near Port Fourchon. I keep wanting to manually change the slide. Please change the slide. The Hurricane Ida did end up making landfall as a major hurricane and as a Category 4 hurricane on August midday local time on August 29th. Next slide. So our partners at Rutgers University have been funded to do model data comparisons, and they've provided some slides as part of this presentation. So here is the operational output from RTOFs and GOFs, and it's showing surface seawater temperature. And this is within the 24 hours prior to landfall of Hurricane Ida. The triangle just off the coast of Louisiana would be NG 645, and that's, I believe at the time, was the only glider asset in the Gulf of Mexico. However, it wasn't the only observational profiling asset that we had in the Gulf of Mexico, because there are several Argo, which are also shown here, that have profiles within the last couple days within the last couple days of this sea surface or sea temperature map. And all of those assets are shown in the circles. So in terms of differences between RTOFs and GOFs, there are some notable differences along the coast, particularly on the Texas, Louisiana, and Florida shelf. Overall, though, in the deeper portion, and this is surface measurements, in deeper water further away from the coast, in general, there's pretty good agreement a little bit difficult to see due to the binning. It's plus or minus maybe 5 degrees C over the course of the entire basin. Change slide, please. Similarly, this is again operational RTOFs and GOFs. This is showing at the 200-meter depth. There are, again, so it has the glider data for NG645 as well as the Argo data. And I should mention that this past hurricane season, some of the Argo and the Gulf of Mexico had switched cycling during peak hurricane season for about a 60-day period. Typically they're surfacing around every 10 days. And then for that 60-day period, there was surfacing on the order of every 2.5 days. So more frequently profiling that upper few hundred meters as it makes its way to the surface in the Gulf of Mexico during this time. So we did have additional profiling assets in terms of Argo data when we didn't have as many gliders out earlier in the season. And then the Argo data also continued later in the season as well. In terms of area and differences, if you look where the loop current and the northern portion of the loop current extension is, there are some differences at the 200-meter depth in terms of the radius and boundary for the loop current versus the cyclonic frontal eddies surrounding the loop current. Next slide, please. Then last, I wanted to show the operational RTOFs and GOFs. This is salinity, surface salinity. And one of the notable things about this slide is that NG645 is one of the only profiling assets in the fresher water barrier layer closer to shore, which in terms of hurricane intensification, the barrier layer can aid in intensification, especially close to shore. Next slide, please. Again, our partners at Rutgers University provided some model data comparison for profile data for NG645, which was the Navy glider asset in the Gulf of Mexico, just east of Hurricane Ida, and the operational model output. So this is for Wednesday, August 25th, which would be about a day prior to the formation of what would then become Hurricane Ida. Hurricane Ida was, it became a tropical depression, I believe on the 26th. So this would have been right before the formation of the tropical depression, which would then be Hurricane Ida. On the left-hand side is the profile for the profiles for water temperature, and on the right-hand side is for salinity. Profiles are shown for individual profiles in the light blue for all the glider profiles within that time period. The final profile would be in the darker blue, GOFs in red, RTOFs in green, and then Copernicus in purple. And on the left-hand side for temperature, one good thing to note is that in terms of the 26-degree isotherm, there seems to be pretty good convergence for where the depth of that isotherm is. As you go further down in the profile from the 40 meters down to about 200 meters, there is some variation in the temperature profiles, kind of oscillates a little bit plus or minus, but seems to have the general profile for the temperature profile. On the right-hand side for the salinity, there are not quite getting the barrier layer correct in terms of that upper 20 meters or so, maybe less for that surface salinity or surface fresh water. And then as you look at the profile a little bit further down in the 50 to 100 meter range, well, GOFs gets it a little bit better than operational RTOFs in terms of the shape of the profile. So we'll go to the next slide. So this would be Thursday with the formation of the tropical depression for Ida. Again, for the left-hand side surface temperature, there's general convergence for around the 26-degree isotherm. RTOFs in the 30 to about 200-meter range is underestimating the available heat for that profile range. On the right-hand side, if you look, there is better convergence for RTOFs for getting the barrier layer closely resembling the glider data profile, which is great. But then it still has some problems with the 50 or I don't know, 30 to 150 meters in getting that higher salinity range correct. Whereas GCOOS has the surface barrier layer a little bit more wrong, which is more accentuated by the scale, but it has a better time getting that subsurface max correct. Next slide, please. So between Thursday and Friday, and maybe even a little before that, another thing to consider, which I didn't mention beforehand, is the location of the glider. During this time, the glider is starting to traverse outside of the loop current and go in between that boundary from the loop current into the cyclonic eddy. So there are some model resolution concerns in terms of getting that boundary correct and whether or not that's able to be seen within the model. But there is about a 24-hour data assimilation cycle for the data profiles. So here, as it's making the transition, or as it made that transition within the last 24 to 48 hours, we do see for the left-hand side for temperature, GCOOS and RTOFs are underestimating the available heat for the profile, especially down to about 300 meters or so. On the right-hand side, though, RTOFs is still having pretty good convergence in getting that upper barrier layer correct, which is great, but still having problems subsurface for that maximum salinity, again, within the 50 to even deeper now, about 250 to 300 meter range. One more, please. But what we do see is 24 hours later, and this would be about 24 hours before landfall, give or take. For Hurricane Ida, we do have better convergence for the temperature profiles. So again, we see pretty good convergence for the 26-degree isotherm down to about 150 or so. And then we start to see more variation again to about 150 to 300 meters or so. Again, on the right-hand side for the comparing the salinity profiles, same story that I've been mentioning over the last couple slides. Operational RTOFs is getting the barrier layer correct in terms of depth and the salinity, but having a little bit more problems in getting the subsurface salinity correct. And again, it's accentuated by the profile scale. All right, next slide, please. So I do want to transition so that was Hurricane Ida. I do want to transition to what are we doing now? We do have a significant amount more assets in terms of gliders available in the Gulf of Mexico now. We've really deployed, I think we deployed, I want to say 6 gliders offshore within a couple-day period at the end of September. So we really filled in some of the spatial and temporal need for the glider data in the Gulf of Mexico. I do want to highlight most of the slides that I have from here on out are screenshots from Gandalf. So if you do want to follow some of the glider activities that we're doing in the Gulf of Mexico, I highly encourage you all to visit gandalf.gcoos.org. I can't give enough praise to Bob Currier for making the model layers available, and has been super receptive to fulfilling the needs for the glider operators and making this a glider tool that we all use in the Gulf of Mexico. So thanks, Bob. So next slide, please. So what I've done over the next few slides is just kind of highlight the different trajectories that we have available. It's a little bit hard to see, so kind of just highlighted over them, and I'll talk a little bit about what their missions are, how long they're going to be out, and what areas or features we're trying to target. So this screenshot was from a few days ago, within the last week. So on the off the Florida shelf, we have a moat glider that was out, I believe it was out for about 2 weeks or so. Typically, as I mentioned earlier, both moat and USF typically do shelf missions on the Florida shelf. Missions usually last around 30 days and usually target red tide events. So this particular glider, like I said, was out for about 2 weeks and I believe was recently recovered. Next slide, please. So another glider that we have out is a USM glider. It's a sea glider, and it's been deployed for a little over a month now. The target area is the cyclonic eddy in the northeastern Gulf of Mexico around the DeSoto Canyon area. And this is actually the eddy that was targeted for NG645, which is the glider that was out during Hurricane Ida. Not only, I mentioned beforehand, but this area definitely sees some barrier layer profiles. So it's really good to have, or has the influence of the barrier layer there, which you're able to see in the profiles. So it's really good to have that glider targeting that area to try to get the barrier layer correct. In terms of overall mission, I mentioned before that it's been out for about 30 days, and I think Stephen Howden was on the call earlier, and he can correct me if I'm wrong in the chat, but I believe this mission is funded through Shell as a partnership for the hurricane intensification partnership with NOAA and the Navy, as well as Shell. Target pickup would be within the next couple weeks. Next slide, please. So there's also a Texas A&M glider out. It was also deployed about a month ago. We had kind of a glider palooza, not separate. So USM did their own deployment in the DeSoto Canyon area, but there were 5 gliders and 3 surface drifters that were deployed off the Texas shelf break at the end of October. So 5 gliders, 1 day, 3 surface drifters, glider palooza. So my group was a part of that. That's the most gliders I've ever deployed in 1 day. So if that's, if anybody else has a record, I know this was very stressful for me and my group. My hat's off to others that do that many deployments in 1 day. So for the Texas A&M glider, this is a Shell-funded glider. It was deployed off the shelf break, and it's made its way pretty much across the Gulf of Mexico, heading towards the loop current and the loop current eddies. Again, it's a partnership with Shell, the Navy, and NOAA in order to provide data for hurricane forecasts and intensifications. This glider specifically is targeting the cyclonic frontal eddies as well as the loop current. I didn't mention beforehand, but it's kind of evident by the trajectory for the USM glider. It's following a nice triangle pattern in that cyclonic eddy. For the Texas A&M loop glider, it's going to make its way towards the center of the loop current and then head back out and then try to capture the frontal eddy if it's still there by the time that we loop back out of the loop current. It's been out about 30 days. Target deployment or target mission length would be around 90 days. depending on monitoring the battery life and other circumstances. So that's the plan for the Texas A&M glider. Right, next slide, please. So the other part of Glider Palooza from deploying the single day was 4 Navy gliders. So you can see a little bit better, I didn't highlight them. But from the single point, you can see 5 gliders going in different directions towards their specified missions and mission trajectories.
Previously, when we were using spreadsheets, we were heavily meeting dependent. It took us hours to update our tasks and our projects. It was crazy. We found out about Monday.com WorkOS, and the instant I started playing with it, it was like a light bulb went off.
Can you hear me now?
Yeah.
Perfect. Okay. So 4 gliders were also deployed in the northwestern Gulf of Mexico. So more like the specified triangle trajectories that we see for the USM glider is the oscillating triangles for the 4 Navy gliders in the northwestern Gulf of Mexico. This specific area was targeted because it tends to be an area where Argo don't stay. There tends to not be a high retention rate for Argo in this area. And if I had the forethought, I would have had an additional slide to back up my claim for that. So I'll add that to my list for next time. So unfortunately, right now, you'll have to kind of take my word for it. But the target area for these 4 gliders and having the repeated triangles was really for that reason. I didn't mention beforehand, but the glider profiles are on here, and then the dots that are shown there are Argo profiles. Oh, thank you. I think Bob just mentioned that in the chat as well. So those are Argo profiles that you can click on and you can compare for co-located measurements compared to the glider profiles. Next slide, please. So the last glider trajectory that I want to highlight in the Gulf of Mexico is what we've been calling the experimental glider track, which Carl mentioned earlier as part of his presentation. So our very own Bill Lingsch deployed this glider off the coast of Louisiana. And I believe, Bill, that was your first glider deployment, right? So yay, awesome. It was deployed on the edge of the loop current, and it made its way down towards the center and then has made its way back out of the loop current. It's been deployed for about 2 weeks, so you can only imagine the strong current and how fast everything has been moving for that. So we've had to keep a watchful eye. Unlike the northwestern Navy gliders that we have kind of following the triangle patterns, the plan for the experimental glider is more of an adaptive sampling type trajectory. What we really wanted to do is kind of oscillate between that loop current and frontal eddy boundary area. So that's one portion of the mission. And again, this is a Navy glider. So coordinating with our Navy partners and having that partnership, not just with the Navy, but across regions. So if you can go to the next slide, please. So this is just a zoom out to give a better idea of where everything is in the Gulf of Mexico versus some other platforms that are out collecting data as part of this glider effort. Next slide, please. So I still have the experimental glider trajectory highlighted in the light blue. And what I've added in white is a sample trajectory for the rest of the mission. So we do want to spend another few weeks in the Gulf of Mexico, kind of oscillating in and out of the loop current and those frontal eddies before making its way through the Florida Strait with hopeful pickup off the coast of South Carolina. Again, it's a multi-collaborational event with several institutions across several regions. It's a Navy glider. There's partnerships with IUS and with different regional associations, and of course with AOML. So we've been meeting to discuss the overall trajectory and the plan and coordinating pickups. And one of the really great things about this mission versus some of the other glider missions that we have, if you can go to the next slide, is that we're able to cross into other EEZs. So one of the limitations almost that we've had in the past with some of the glider profile or some of the glider data is typically without permission for entering into other EEZs, we've kind of had to stay in our own areas. And then there are ways to formalize that through going through the State Department. But there are some advantages for utilizing the Navy asset. So they are able to go and cross into other EEZs, which will be especially important as we head into the Florida Strait, which I'm very excited for. Next slide, please. So I'll end with some future plans to finish out the season. We're going to monitor the power consumption. I mentioned that a lot of our assets were deployed at the end of September. So in terms of battery consumption, if you're sampling as fast as possible and you have a thruster, you can typically count on about 90 to 100 days for a mission, depending on sea state. So we will try to use the extent of the battery packs as much as possible, but we do want to leave enough room for a safe recovery. So we'll continue to monitor the power consumption. I showed some model data comparison leading up to Ida. But we do want to have a continued analysis for the Hurricane Ida data heading into the off season. So the data that's sent back is a subset of the overall data that's available, and that full data higher resolution set will be available once we recover the gliders and be able to download it back in the lab. And then last, we talked a little bit about this in the last GCOOS spring meeting, but we want to continue to encourage opportunities for co-located measurements. It's really important, especially for hurricane research, to have not only ocean data, but meteorological data as well. So as opportunities become available for having sail drone or SV3 data and having subsurface profiles, or surface drifters with gliders, we wanted to continue encouraging having and leveraging the different assets available. Last slide, I think, are just links for different things that were shown throughout the profile or throughout the presentation. And that's all we have. So thank you guys so much, and happy to answer questions.
Well, thank you, Kerri and Bill. You know, I talked to Carl earlier. I mentioned to him, you know, the potential lack of enthusiastic young folks trying to get and work in our community. If you listen to Kerri's voice and you watched her smiling, the enthusiasm just radiates, and that's so encouraging moving ahead. And the other thing that you want to remember is that Kerri and Bill just aren't always sitting in their office or in their living rooms analyzing data. They're out in these small boats in the middle of the Gulf of Mexico, and boy, they're rocking and rolling, literally. And that's not the most comfortable thing to go through, but they're going out there and they're doing it, as are all the glider deployers. I mean, there are many people out there that are doing it, but it's not an insignificant undertaking. And I give you a ton of credit for what you're doing. This is really exciting stuff. Unlike the hurricanes, we're finally getting gliders that once they're in the Gulf can actually leave the Gulf. And that's really, I can't wait to see what happens when that glider gets further south toward the Florida Strait. That's going to be very interesting. So well done, guys and ladies. I mean, you're doing a great job. And to Bob with the Gandalf, I get messages from Bob almost daily on, well, I added this to Gandalf, I added that to Gandalf, and now I added that. It's unbelievable how productive he is and how realistic a picture the Gandalf really can present. So if you haven't looked at Gandalf, I highly encourage you take a look at it, and you'll learn a lot. Okay, enough out of me. There's a Pat Hogan. You got a question?
Yeah, that was a great talk, both Bill and Kerri. Well done. I always love glider stuff, and especially when you look at models. I guess two comments or questions. RTOFs and GOFs. Yeah, okay, those were kind of differences I expected. It looked like Copernicus may be outperforming both of them, and I didn't know if you came to that same conclusion, which is interesting in and of itself. The other question, I guess, is on the adaptive sampling, the experimental glider. So with adaptive sampling, you're typically trying to minimize something in a cost function or maximize it, whether it's maximizing battery life or minimizing forecast error or whatever that might be. Are you using, like, well, Bill, you'll know what I'm talking about, Ghost or some kind of, adaptive sampling software where you're minimizing some aspect of a cost function? And if you are, what part of that cost function are you trying to minimize?
That's a great question. Do you want to answer that, Bill?
Well, I'll just answer the early part with NRL and Greg and Charlie on Ghost. We have reached out to them to see if they want to get involved in this mission for that purpose, to actually have them play in this experimental mission and actually use Ghost to guide it as part of optimizing, like, the cost function that it used for the energy budget. So yeah, I think that would be a great sort of complementary effort from the Navy side as well in this mission, Pat. So yeah, we have reached out to Lucy and Sean.
So that's a really long deployment. Is that one battery life deployment?
It is, yeah. So the target would be a single battery. It's a lithium battery. And we do have some wiggle room depending on how things go in the Gulf of Mexico. Once it gets through the Florida Straits, we're going to be moving pretty fast. And through the Gulf Stream, there'll be less opportunity. We can still slow down, but there'll be a little bit less opportunities. So we have a little bit more room to circle and go in and out of eddies in the Gulf of Mexico. It doesn't necessarily have to be picked up off the coast of South Carolina. We have partners from Miami or the Key West all the way on the East Coast. So we do have wiggle room in terms of battery consumption. It doesn't have to make it to that point because we do have several partners that are ready and able to pick up the glider if it need be. Even in the Gulf of Mexico, if there happened to be a problem and we hopefully don't cut anything short, there are still those opportunities, and which is really important for the different regional collaboration for this specific mission.
Yeah, and Pat would in today's meeting with Kerri and Robert Todd, it's been in for 16 days now. So we took what it's done in the 16 days when it's been in the current and then coming up, and sort of looking at extrapolating that out to the rest of the mission as well. So we got sort of a little bit of baseline on how far we got in 16 days and how much energy.
Yeah, so I did notice the white line and the blue line were pretty different. So
the white line is the initial. The white line was the initial sort of drawing, and like Kerri said, the coordination with the GOC and things that were going on, and it's offered another challenge, but still great data, right, Kerri?
Yeah, good stuff.
Absolutely.
Thanks a lot.
Yeah, absolutely.
And hopefully this sets up plans for next year too, for the operations next year. So that's what's critical too about this. And hopefully the snapshot you see now is what we'll see in May, June, right?
Any other questions?
And I just want to shout out to Kerri because this is a collaborative effort, but she has the lead on it. So, you know, she's working with Robert and Catherine, and I know I'll leave somebody out, Kevin and Steven and everybody, but ultimately she's the lead on it. So she's doing a super job. So that's why you see that big smile on her face. So she gets nervous at times. So.
I do. Thank you.
To make things in the Gulf even more interesting, we have a company that has just established its Gulfport, Mississippi operations called Oceanographer. They're based currently in San Diego, and they're about to move their entire production and operations capacities to Gulfport. And Bill is in, and Jorge have been working with the lead in Gulfport, Bob Caniglione, to see where we can go with them. That's basically a sail drone and a submersible glider all in one, and could be a real exciting opportunity coming real soon. Bob was supposed to join us today. He's on a cruise, and apparently he didn't get enough bandwidth in his data package on Carnival Cruise. So, but he'll be back in town on Sunday, and we'll capture him, and he'll be able to watch the recording of the presentation. But another exciting opportunity. This is getting really good.
I need to tell you too that Sail Drone has just announced that they're opening an office in St. Petersburg, right next to the USF College of Marine Science campus.
That's great.
Yeah.
Joe, this is Carl. We also are the Oceanographer vehicle, the submarine, I think they call it, has been doing pilot work for HAB forecasting in the Pacific Northwest at NANUS and doing. I asked them if it would be feasible to do water samples, and then they connected with NANUS and the scientists there, and they figured out a way to do that. And so that's something that's when they do this submarine version, you might be able to get samples at depth too. So that would interest folks for all sorts of parameters, like if you're getting samples for DO or other things.
Absolutely interesting. Any other questions or comments? Okay, if not, no, go ahead.
Yeah, I think Brian had one in the chat about expanding to the shelf, and I would say,
Brian.
Yes, I would absolutely love it to expand the glider missions to the shelf. We do pretty regularly with the partnership for MOAT and USF for coverage on the Florida shelf. I would love to extend that to Texas and Louisiana and off of the Florida Panhandle. There, as you mentioned in the chat, there are physical concerns in terms of boats and obstructions, but that's something that we can definitely work around in order to try to get that valuable shelf data. So and that's something that we've talked about as a GCOOS glider group for expanding across the shelf. But of course, there's always funding concerns as well. But we do have assets available to do that in the future. And I would say that that's something that should definitely and has been it has been in our build out plan for the Gulf of Mexico. And that's something that I would like to see in the future as well.
Thank you. Yeah. It was just interesting to see that striking difference between what the East Coast does, right? And then sort of very different physical oceanography, right? You know, like the Gulf, the mid section of the Gulf, right? The storms can go anywhere, and there's some significant features there, but it was just kind of interesting to see that contrast.
Absolutely. And it's something that we know as, I'm not sure if it was highlighted on one of the slides, but as an essential ocean feature in the Gulf of Mexico, having that, especially during hurricane season, having a very warm, long, shallow shelf. So having that available heat and the impacts for intensification as the storms move closer to the coast is very important in terms of forecasting. So that's definitely something that we would like to see moving forward.
And maybe someday we'll get to the point where we can go down to the pier, put the glider in the water, and send it on its way.
Yeah, and one of the things, that IDA showed was that the seafloor is the ultimate barrier layer. So there's no cold water to mix below it.
Yes, and we've seen that with Harvey as well. So that's definitely something that we've seen over and over again in the Gulf of Mexico.
Other questions or comments? Okay, if not, I'd just like to thank Dr. Whilden and Mr. Bill. Thank you so much for all you're doing. The Glider user group is just great. And I know you're reaching out internationally because I know the Europeans are very active in the world of gliders, and perhaps even well, we know the Caribbean nations, AOML has been involved down in the Caribbean big time. There's so much to do and so much that can be collaborated with. It's really, it's an exciting way ahead. So thank you all for your, yeah, Bill.
Can I do a 10-second plug just real quick too for any of the audience here that may not be a member of the UG2? You can go to underwatergliders.org and join and get all the updates. We have webinars every 2 months. The recent one was about piloting and the challenges on different missions and how they, overcome or even fail, due to different scenarios in the physical ocean conditions. So please join. It's very easy, underwatergliders.org. Thank you.
Great. Okay. So again, thank you very much for your presentation. It's a ton of information, but it's excellent work. Thank you. Well done.